Hello everyone, good afternoon. I'm Georgy Kucherin, and I am a security researcher at Kaspersky's Global Research and Analysis team. And at this team, my task is to analyze sophisticated malware that is used in targeted attacks. And these threat actors that use such malware, they are commonly called APTs, or Advanced Persistent Threats. And over the years, the cybersecurity community has managed to uncover a lot of APTs, and a lot of them have been running for many years, some of them even since the 1990s. And these APTs, as they have been working, they have been mastering their skills of getting inside organizations, then keeping their presence inside them, also finding files that could be useful for attackers, and silently exfiltrating their files to their own servers. And every now and then, we hear news about one or another APT. For example, a few weeks ago, we learned that Lateral, a Korean-speaking APT, now targets organizations through infected PyPI packages. Or, we recently also learned about activity of the Midnight Blizzard APT, which has been known to compromise several organizations that are very known worldwide. However, amid all those news, I noticed that there has been a lack of information about one particular APT, which is very interesting. And this APT is APT41. It is a Chinese-speaking APT, and you may also know it by the names Barium or WinNTI. It started its operations in or around 2012, and it has been notoriously known for conducting supply chain attacks. They started to conducting these attacks in about 2014, and their first targets were small development companies located in Asia. However, over time, they decided to hunt for bigger prey, and in 2017, they have successfully managed to compromise the CCleaner software and plant malware into it. And the software, it was used at the time in millions of computers around the world, and it still is actually. But it was not the only memorable supply chain attack of APT41, as a few years after compromising CCleaner, they did another compromise of the ASS Live update software, which also targeted a lot of computers. However, what it's important to say about these attacks, although millions of computers were compromised, APT41 chose only about 100 of them, and it performed exfiltration only for these computers of their choice. So these supply chain attacks, they were still carried in a very targeted manner. And the activities, they raised so much attention that many law enforcement organizations became thoroughly investigating activities of APT41. And in 2019 and 2020, the FBI has issued indictments against members of APT41. If you have been following threat intelligence news, you likely recognize this poster over here. However, these indictments didn't stop APT41 from operating, as in 2021, APT41 came with yet another attack, which now involved UEFI bootkits. Well, apart from doing those cyberespionage attacks, APT41 members do something else. Like, every black hat hacker who does real hacking for not just for bug bounties, but for real hacking operations. They want to live in large houses and drive in large cars around the street and boast to everyone that they have all those assets. And to buy all those cars and houses, you need a lot of money. And what they also do, part-time from their cyberespionage activities, they also try to earn money with cybercrime. And they do it in a very unique way, by hacking online games. A lot of online games, they have some kind of virtual currencies or virtual items that you can exchange for real money, And what they do during the operations is that they hack into the game and then manipulate databases in order to change the virtual currency into real money. That's what they do. And since they have been doing it for a lot of years, it turns out that their activity is quite profitable. And actually, in January 2024, I had a chance to investigate an infection of a gaming company located in South Korea. And the techniques and procedures that we observed during this infection, they allowed us to gain a spotlight into the recent activity of APT41, since they indeed resembled activity of this APT from the past. And so, thanks to this investigation, we are able to find out what techniques they use nowadays. And so, let's together dive into this incident. And by the way, while I'll be explaining how APT41 managed to compromise the organization, I'll be asking you questions about malware analysis and threat intelligence. And in case there are malware analysts in this room, you can get prizes from me. So, let's get started. As you know, every compromise, it starts with an initial infection. And APT41 is known to do this initial infection in a large variety of ways. For example, to hack CCleaner, they obtained access to a user account on TeamViewer, which is a remote control software. And nobody still knows how they did that. Maybe they used some leaked credentials, but that's just speculation. Or another thing they were observed to do, they took exploits for vulnerabilities that have the advisories for which have been recently issued, and they have been trying to hack companies using these vulnerabilities. And in our case, they also somehow ended up infecting our gaming company, and they managed to gain access to a low-privileged account. However, in order to progress with their attack and get to the virtual currency manipulations, APT41 now needs to gain access to some high-privileged account, preferably a game developer. Now, when you perform lateral movement inside an organization, there is always a set of methods that you can try for every single company. For example, you can try and see what user accounts are available in the organization and then perform password spraying against them. Or you can use the corporate email to send phishing emails to other employees, or check what services are available inside the organization and try to find vulnerabilities in them. But as I said, these methods are very popular, and as such they are very detectable by antivirus solutions. And since APT41 does not want to get detected, they decided to perform lateral movement in a way that is tailored to the infected organization. And to see what they could do, they decided to perform more reconnaissance of the organization. And as part of their research, they have found out that the gaming company had a shared network drive available for all employees. And in an organization's security chain, well, these network drives can be a weak link, because it's actually quite difficult to scan those network drives with antivirus solutions. All the files on such network drives, they can amount to hundreds of gigabytes in size, and imagine what happens if you run an on-demand scan of all these files with an antivirus. The scan will run really slowly, and access to the drive itself will be very slow while the scan is running. And likely APT41 knew about this fact about network drives, and they decided to use it for further exploitation. On this network drive, they found a lot of stuff related to the gaming company. However, what they turned out to be particularly interested in is in a folder related to the game development. By searching this folder, they found out that it contained a batch file designed for uploading changes to the game servers. And as everything in this organization was 100% secure, this file turned out to be editable for everyone. And When APT41 discovered this, it was game over for the gaming company. What they did is they decided to plant a line of malicious code inside this file. And once they did this, all they had to do is to wait until some developer decides to push updates to the game. And as time went, they got what they wanted. One of the developers ended up opening the file, and through the MSI exec living off the land binary, they ended up downloading this MSI installer file. This file contained two things: a malicious DLL, we'll talk about this later, as well as a script for configuring persistence of this malware. And the persistence, it was done in quite a unique way. It involved using COM objects. Well, in case you didn't know, COM, or Component Object Model, is a feature of Windows that allows two processes to communicate with each other. Basically, if you have some API that you want to expose to other processes, you can register it inside Windows by assigning it a GUID, a 16-byte value. And once you do this, other applications are able to query your interface through the Windows API, for example, using this co-create instance API. And a list of all those COM objects is available in the Windows registry under the HKSR key. But using COM objects by itself for persistence is quite common. There is a technique called COM hijacking, which has a separate entry in the MITRE attack table, which describes all popular techniques used by attackers. And this technique basically involves finding legitimate COM objects registered in the system and then replacing them with malicious ones. And actually, since this technique is very well known, it is being hunted for a lot. And one of the possible ways to defend against this technique is collect lists of COM object IDs that are commonly hijacked. And one of such lists was published quite very recently, about a week ago, by VirusTotal. And as well, APT41 is a very experienced APT, so they knew that if they use COM hijacking, they would be doomed. That is why they decided to use COM objects in a quite a creative way, in order not to be detected with this technique with hard-coded COM object IDs. What they did is they registered two COM objects with pseudo-random IDs. One of these objects was configured to be handled by applocker.csp.dll, which is a legitimate Windows DLL, while the other one was configured to be handled by the malicious DLL. And COM objects on Windows, they actually have a lot of features. And one of the features you can do is you can configure one object to be redirected to another one. As such, when you query an interface of the first object, this query actually gets handled by the second object. And this is what APT41 did in this case. And in order to configure persistence itself, they created a schedule task that would query the interface of the first COM object every day. And as you can see, all this is required just to launch this malicious DLL. Now, the schedule task queries the interface of the first object. Since the first object is redirected to the second one, then the DLL corresponding to the second option will end up executing. But why do all these things just to launch a simple DLL? Well, the answer to this is defense evasion. And to understand exactly why this technique helps evade against security solutions, let's look at this description of a schedule task. This is a textbook example of how you can launch a DLL using schedule task. It's in an XML format, and as you can see, the arguments field of this XML contains the path to a malicious DLL. Now, since schedule tasks are often used by attackers for persistence, it makes sense for an antivirus scanner to run a scan of every scheduled task available to triage if it's malicious or not. in this textbook case, an antivirus solution, since well it's a textbook case, it should be able to easily find the path to this DLL, and it should be able to tell that this is something malicious. However, in the case of what APT41 did, the description looks like this. As you can see, it does not expose the path to the DLL. And so, if an antivirus solution looks at the description of this task, it needs to be able to match this ID that you see on the screen with a DLL name. And it needs to do it correctly, because if, for example, a security solution doesn't know anything about COM object redirection, then it will just say that the COM object is managed by app-locked CSP, which is a legitimate DLL, and thus it will in the case theoretically declare that the scheduled task is legitimate, while it's not. So now that we learned about how APT41 did persistence in this case, let's look at the malware implant itself. And by looking at the scheduled task description and matching the COM objects, like I told you before, well, it became possible to identify the path at which the malware was dropped. And this path looks like this. However, at the end of this path, we have this thing called zone.identifier. Anybody knows what this is? Yeah, you're correct. It's called an NTFS file stream. And NTFS file streams are a concept of the NTFS file system that allows you to store metadata about a file. And it was correctly said, the zone.identifier stream, it contains information about origins of a file. For example, if you download a video from the Nullcon website, and if you look at the contents of this stream with the more utility, then it will display that the website from which the video was downloaded is indeed nullcon.net. However, in our case, attackers decided to misuse this NTFS stream and instead of writing information about origins, this NTFS stream contained a malicious PE file. Upon extraction, it turned out that this PE file is a loader, and the payload inside the loader, it was encrypted with an RC6 cipher, and in order to continue the analysis, it was necessary to code a decryption tool. Now, in malware analysis, in case you are dealing with encryption or decryption, a common tool you use is called cyberchef. While RC6 is quite a popular cipher, unfortunately, cyberchef did not contain a decryption algorithm for it. Now, what I decided to do next is to look on GitHub for Python scripts. However, all I could find is just some code written by students that contained a lot of mistakes, and it was easy to rewrite the code itself than try to fix those issues. It either crashed or gave incorrect results, so no luck. At the end of the day, it was a very painful process. I had to find the original library that was used by the malware. It was not very difficult to find this step, because it was the first result on Google. The library was called Cyclone Crypto, but it actually took a lot of effort to configure this library to work with Visual Studio. And after some headache pills, I finally decrypted the payload. And it was a backdoor. It contains the functionality you would expect from the backdoor. It collected system information and sent it to the C2 server. And it did this using two protocols. One was HTTPS. It was the primary protocol. And in case the malware couldn't connect to the C2 server via HTTPS, it actually used DNS. And it relayed messages to the C2 server with the help of Google's public DNS, 8.8.8.8. And what's actually notable is that this very same technique of using both HTTPS and DNS, HTTPS as a main method and DNS as a fallback method, was seen by APT41 about 4 years ago. by ESET in one of the backdoors. And in exchange for the system information, attackers delivered commands to the infected machine. The commands were also what you would expect from a backdoor: modifying files, collecting information about the network and stuff like this. But a set of interesting commands, it involved launching additional payloads. It's always useful to check commands that run payloads to check what other tools the threat actor is using. And we found one command which runs one payload. It was a specific PE file, and it had those imports that you see on the screen. However, on one word of the imports, I put asterisk instead of it. And this payload that the malware was handling, it was actually belonging to a very popular penetration testing tool, which is also used by many APTs. Can anybody guess what this payload is? Cobble Strike, yeah. Yeah, beacon. And so this is actually for an APT. By finding out that it uses Cobble Strike beacon, we know what to hunt for. We know that we need to hunt for Cobble Strike if we want to try and catch APT41. That's why it's useful to examine all the backdoor functionality. And after deploying the malware itself, surprisingly, while the backdoor was unique, they then deployed open source tools on the victim machine, mainly LegalNG to get a tunnel into the organization, and then they started performing activities related to credential dumping. They deployed the infect tool, which dumped LSA credentials, as well as the invade tool that allows to perform machine-in-the-middle interception, again for extracting NTLM hashing. It's actually quite surprising to see open source tools nowadays from such a sophisticated APT. I actually expected them to use custom tools, but apparently for some reason they had to stick to open source tools. However, with those tools they were not really able to do anything as the activities were blocked. Dead end. And now that we know what APT41 tried to do inside the organization, it was now time to determine the origins of this backdoor, whether it was used in any other attacks. But actually, we didn't find any more usages of this implant, except for one sample that appeared to be in use for testing. And its development must have been painful because this version of the backdoor, it contained a lot of crash printf statements. Crash, 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 crash. Lots of crashes. Apart from them, the developer of the backdoor seemed to really like the word view. And one of the notable strings was view such null. And actually, such strings can tell us a lot about the personality of the developer, particularly the memes they like. These lines are commonly found in Doge memes, and so we can say that this meme may be one of the developer's favorites. But this is not the only funny thing that was observed in this malware. Another Easter egg, or not Easter egg, left by the attackers is this PTB Pass. PTB Pass provides information about where the malware development folder was on the developer device. And the found PTB Pass, it looked like this: X, work, TAO, implants, violent assistant, release, debug VNA.pdb. And actually, this PTB path, it hints at one of other advanced persistent threats. Does anybody of you know which APT this is? Well, this is the equation group APT. The TAO is known to stand for Tailored Access Operations, couldn't find a better logo on the internet, which is the unit that is supposed to be behind the equation group, as well as the word implant is how they call malware, while the word violent assistant, know that it consists of two words. The equation group implant names, they also contain two words. So, back to our question. How is APT41 doing nowadays? Well, since they're performing their operations, they are unfortunately doing just fine. But what we can notice is that they are doing their things more subtly. We no longer see those supply chain attacks. And this is probably for a reason. Because whenever there is a supply chain attack, it gets very quickly discussed in the cybersecurity community. Like, when I say Lazarus, everyone will say 3CX, the attack that was observed about a year ago. Or when we say Nobelium, the thing that the actor associates is the SolarWinds compromise. And these activities, they gain a lot of unwanted attention. Of course, during supply chain attacks, you can hack in a lot of companies, but still, at the end, when you are caught, you will receive a lot of unwanted attention, which will result in indictments and stuff like this. So, APT41 seems to no longer do this stuff, because it attracts too much attention. Still, they are trying to stay under the radar. They do infect their targets in unique ways. However, this is not like we saw before. And while they are still performing their operations, there is still something we can do about it. Firstly, we can thoroughly analyze all those incidents and extract all those unique ways of compromise, like the one with the network drive or the one with the COM object persistence chain, and spread awareness about all their unique tactics. By doing this, if we do this effectively, we'll be able to drain the imagination of APT41, and it will make it very difficult for them to create new techniques. And another thing we can do is try putting more efforts in detecting open source penetration testing tools, such as Cobalt Strike, LegalONG, and many others. So, APT41, they seem to develop backdoors that are quite unique. However, it looks like that they may not have enough resources to develop secondary tools, like the ones for tunneling or for extracting NTLM hashing, and that's why they likely have to resort to using open source tools. So what we can do is try to detect all those open source tools, implement many detection mechanisms for it, and as such, when APT41 starts using those tools, they'll get detected at a stage where they will not manage to do much damage to the infected organization. So, if we follow all the steps, then it will likely be more difficult for APT41 to target more organizations. So, that's what they do in 2024. And now, if you have any questions, please don't hesitate to ask them. Thank you.
Any questions?
Nice presentation, thanks. How did you attribute this to APT41? Just by memes?
No, actually. Well, I told that there are a lot of tactics and techniques. First of all, it's a gaming company. Like, gaming companies are not very popular targets, and when you see a gaming company, specifically located in Asia, when APT41, you suspect it. And then they use techniques that have been observed in other reports, like the one with the DNS and the HTTPS, and others.
Cool, thanks.
Thanks for the presentation. I was wondering if they used open source tools after all this work beforehand. Could there be a chance that they use custom tools for the espionage tasks? so that when they do their free time activities to earn money, they don't want to burn the actual tools they do for the government work they usually do.
Thank you. Maybe that's the case. Well, we can only speculate about it, but maybe that's what they do. But they have been observed using open source tools before. It happened just they have been using it for open source tools were observed by them about 2 years ago, I think. So that's what they do.
Right, nice presentation. I had a question. So you mentioned Tau. So was the implant one of those which was leaked by the shadow brokers, or was this something which was not already in the open domain?
Well, thank you for your question about this PTB Pass. Well, I don't know the reason why they exactly put it. Maybe it was a false flag, but it's a rather obvious false flag because the creation group does not use open source tools. Huh? Sorry, what? I don't hear. Can you please speak into the microphone?
One of the backdoors was mentioned as being violent assistant.
Yeah, violent assistant.
Yeah, so was that leaked by the shadow brokers, or was this...
No, they just made this name up to mimic the naming style of the equation group. It's just a parody.
I have one question. How was the first detection? Because you're sharing the timeline of the attack as you reconstruct it. But can you share what was the first thing that allowed you to detect this and start unraveling this?
Well, what we saw is manipulation with COM objects and then deployment of this backdoor and those custom tools. So they did it in a quite short time frame. So I showed the historical timeline of the history of APT41, but this whole chain of attacks was actually conducted in a fast way.
Thank you.
Any more questions? No? Then thank you.